Buckle up, everyone! We are going to defeat NASA's optical lies and reveal the wondrous flat Earth from space. The truth will not be suppressed. Let's have a look at the gateway to astronaut photography of Earth. This website is a goldmine. So many photos and high resolution too. Let's browse and I'll show you what I mean. Let's go ahead and click on the collections and then time lapse. And here we have some filter parameters. Let's go with 2025. There's a lot more data sets. And we can choose day or night or day, night. I'm gonna go with day. And let's filter. Now let's scroll. There's probably hundreds or more file sets, and each has hundreds of photos, if not thousands, especially for the longer tracks, as you can see. So let's go ahead and pick this one on December 16th as an example. So now there's all the photos cataloged. We can see the focal length, so much information, and these are huge photos taken with the Nikon Z9. See, we get some information, 21 millimeter focal length, camera information. Let's click on metadata. And here we go. Yeah, we have the metadata. We can see some of the parameters. You know, the astronauts, I think, need some training on how to set the camera properly, because they have the parameters kind of wonky, you know. The shutter is too high, aperture, and it's a little bit dark. But anyway, we can download the raw image. And we can also hover and see the data. Look how noisy it is. They have the ISO turned up. Yeah, these guys need to have a class in photography. So here's the photo I downloaded. Very noisy and dark. Yeah, they did not set the parameters correctly. But at first glance, you may think this is normal. Look, the solar panels are straight. They're in space. The Earth is a globe. Praise the Lord. But hold on a second. Don't get ahead of yourself. Because we are dealing with some incredible optical distortion, as you can see here. The solar panels are straight, yet they're curved, almost the same as the horizon. Isn't that incredible? So this is a dead giveaway that we're dealing with the fisheye lens phenomena. So let's have a look at the optical distortion zones. This graphic illustrates what we're dealing with. We have the camera, and then there is certain lens distortions, right? Usually they're corrected, etc. But for fisheye lenses, we need to understand what kind of image that produces and what the equations are. Then we're looking through the cupola window. And again, distance away matters, what angle, what attitude we have to that window, etc. And then finally, we're dealing with the refraction in the space environment, and plasma and the temperature gradients do affect what we see. So very complex environment. When it comes to fisheye lenses, there's some mathematics we need to be aware of. And don't worry, there's plenty of tutorials online, and I'll have a link for you. And there's also Python modules written for all this, so you don't have to wade in all the details. And last but not least, we have to think about perspective. Can we replicate what these astronauts are seeing? And here I just grabbed 4 images off the internet with some women astronauts, and there's Chris Cassidy, Navy SEAL, engineer, Very interesting careers that these people have. Samantha Cristoforetti, oh, I love that name. She's an Italian Air Force pilot and engineer. Lots of military folks. But Karen Nyberg has a PhD, no military experience, just a smart gal, made it into space. Yeah. So here's a graphic trying to illustrate angles. Depending on how far away you sit from your TV, you may or may not get a proper perspective. And so I set out to actually correct some of these photos and try to produce very pleasing, accurate perspectives brought to your desktop or your TVs in the living room. Okay, so now let's have a look at this Python graphical user interface app I wrote. Okay, I'm primarily using the computer Vision 2 module in Python, and I put some field boxes there, text boxes and labels, so I can rapidly test different parameters. And this is work in progress. This is version 1, and I'll release this eventually, but I'm going to build in a batch file processing capability so I can run over many files and create a time lapse, a corrected time lapse. But anyway, this has made it possible for me to correct the photos. And I also process them a little bit in Photoshop because they're too large, like 8,000 by 5,000 pixels. So here you see I've reduced it to 4,000. And so accordingly, I reduce the pixels per millimeter as well, but keep the focal length. I can shift slightly, and I have the distortion parameters and the K2 parameters. Now, here's a question. Should the horizon be linear? Well, let's do a simple verification here. So I corrected this image based on the focal length and all that. And now I drew this line between some features which we can measure on a map. Okay, so we have the San Gorgonio Mountains. We barely touch the Salton Sea on the western shore there. And then we go in the Gulf of California to that point. So now let's have a look at a map. Okay, so here's the map, so you can have confidence that indeed these features are all in a straight line. But you may be wondering, wait a second, on a fisheye image, lines that pass through the center will not be bent. And so I've chosen another location to illustrate that when we correct for straight lines on the ground, the horizon comes out straight as well. So here we are. This is in Iraq, and you can see the curved line. And here it is corrected. Now let's look at the map. So here I'm using the measurement tool to lay down a line starting over where the Al Kabur River flows into the Euphrates River. And then on number 2 we have Haditha Dam, and then we barely touch Thal Lake, can barely pronounce that. And then right over to the western shore in Iran. So this is just incredible, folks. When we correct for features on the ground, we obtain a flat horizon. Isn't that incredible? So we can have confidence that indeed the horizon should appear flat. There you have it, folks. The Earth is incredibly flat. Don't you ever forget that.